Okay, today we're going to do a brief introduction of percent composition, and that basically means you're going to be finding out the contribution of mass of each of the atoms in a molecule. And you're not going to do it based on how many molecules are in the compound. You're going to do it based on that mass contribution of each molecule or of each atom. So the first one we're going to look at is copper bromide. Copper 2 bromide is made up of one copper atom and two bromine atoms. You put them all together, you've got your oxidation numbers, which we've reviewed, and you make yourself a molecule. So we're going to start by you'll need a periodic table nearby, and you'll also need a calculator nearby. We're going to look at the periodic table, and it shows us that 63.546 grams are in 1 mole of copper. So this is for 1 mole of copper. And again, we're always talking about moles. We don't talk about individual atoms because that just would be too difficult to measure. If you look at bromine on the periodic table, atomic number 35, you'll see that it has a mass of 79.904 grams in 1 mole of that. The other thing that you'll need is you'll actually need the total mass of copper bromide. Now that is going to include one of the coppers plus 2 of the bromines because there's 2 of them. Okay, so when you put this in your calculator, you're going to take 63.546 and you're going to add 79.904 plus another 79.904, and altogether you'll get 223.354. Now if you look at your sig figs, there's 3 decimal places here, 3 decimal places here, and 3 decimal places. So my answer can only have 3 decimal places. In order to calculate the percent composition of copper, okay, we're going to use a different color here. Copper is going to contribute 63.546 grams total because there's just 1 mole of copper in this molecule. Out of the total amount, which is 223.354, and you're going to multiply it by 100. Okay, so if you put that in your calculator, 63.546 divided by 223.354, and you multiply it by 100, you're going to get 28.45, and you just keep going on and on and on, 28.45 something. But if you look at your sig figs, okay, you've got 5 sig figs here, and you've got 6 sig figs here, and if you look at the least amount of sig figs, you're going to see that you can only have 5 sig figs. So we're going to knock it down to 28.451% copper. That was what would go in the blank over here. Okay, if you go to bromine, you could do it two different ways. First, you could add up 79.904 twice and put that in the numerator and then divide it by the denominator just like you did with copper. But the easier thing to do, since there's only 2 elements here, is to just subtract this amount from 100 and you would get 71.549% bromine. And those are your answers. Okay? All right, let's try another one. Okay. The next one we have is sodium hydroxide. Okay. So we're going to look at sodium hydroxide, and sodium hydroxide is composed of sodium, oxygen, and hydrogen. 3 atoms. Okay. If you look at your periodic table, sodium is 22.990. And that's how many grams are in a mole. Oxygen is 15.999 grams in a mole, so that's how much mass the oxygen is contributing. And then hydrogen is 1.008 grams in a mole. So that gives each individual atom that's contributing, or excuse me, a mole of each individual atom that's contributing to the whole. But we also need the mass of the whole compound, because then you can do your division. So if you added up these three elements, 22.990 plus 15.999 plus 1.008, and you would get 39.997 grams are in 1 mole of sodium hydroxide. So here we go. For sodium, the percent sodium, we're going to use 22.990 divided by 39.997. Both of these are grams, so they cancel. Okay. So if you put that in your calculator, 22.990 divided by 39.997 times 100, and you'll get 57.4793 blah 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 blah. But if you go back and look at your sig figs, there's 5 sig figs here, and there's 5 sig figs here, so the answer can only be in 5 sig figs. So the percent composition of sodium is 57.479%. So that's the answer to that one. If you look at oxygen, the percent oxygen is 15.999 divided by the total, which is 39.997. Both of these were grams per mole, times 100. So let's put that in our calculator. Divided by 39.997 times 100, and you get 40.0005, and then more numbers. So the percent oxygen here is going to be also 5 sig figs. So 1, 2, 3, 4, 5, and that's the percent oxygen. Okay. So this is your percent composition of oxygen. Even though there's only 1 oxygen, 1 hydrogen, and 1 sodium, it's not going to be 33% each. It's actually going to be based on the mass of each. So sodium brings to the table a lot of mass. It's 23 grams per mole, whereas oxygen's almost a little over half of that. So sodium's going to have 57% of the total mass, whereas oxygen's going to have 40. If you look at hydrogen, since this is the last component of this compound, instead of adding it up or dividing it rather, you could just subtract it from 100. So if you take 100 minus 57.479 minus 40, you get that hydrogen is 2.521% of the total mass. This is the composition of hydrogen. This is 4 sig figs, just like you just had 4 sig figs over here. Okay? Let's try one that's a little bit more challenging, and then I think you'll get it. So the bottom line of the percent composition is that you're just basically trying to find the mass contribution of each element. This one's a little more tricky, but it's made up of nitrogen, hydrogen, and sulfur. So if you look at just those individual atoms on the periodic table, nitrogen is 14.007 grams in a mole. Hydrogen is 1.008 grams for each mole. And sulfur is 32.066 grams in a mole. Of course, we need the whole compound, but we need to be careful here because we need to look at how this compound is made. Basically, when you have these parentheses here, this is sort of like a multiplication in math. So, for example, if you had a 2 and then you had a parentheses 2x plus 7, that 2 would have to be distributed to each thing inside the parentheses. The same thing happens here. This 2 in ammonium sulfide has to be distributed. You would not write it this way, but let's look. You actually have 2 nitrogens. You have 8 hydrogens because that 2 is distributed. 2 times 4 is 8, and you have 1 sulfur. So in order to find the entire mass of this compound, you would have to multiply 2 nitrogens, 8 hydrogens, and 1 sulfur altogether in order to get the total mass. So let's get that in your calculator, see if you can beat me. Okay, we're going to do 2 nitrogens. 2 times 14.007. If you're using a calculator, you may want to use parentheses because that's going to really help this go faster. You need 8 hydrogens. 8 times 1.008. Then you're going to add in 1 sulfur. Okay. When you put them all together, you should get 68.144. And if you look at your decimal places, for our sig figs, there's 3 decimal places here, 3 decimal places, 3 decimal places, so our answer can also have 3 decimal places. So there's 68 grams in 1 mole of ammonium sulfide. So now let's look at our composition. Okay. So if we wanted to know the composition of nitrogen, the total composition of nitrogen, you have 2 of them, so instead of having 14.007, you have 2 times 14.007 on the top. This is the times, okay? And then over the total amount, which is 68.144 grams. Okay, and multiply that times 100. So let's see what we get. 14.007 times 2 is 28.014. Divide that by 68.144. Multiply it by 100. And the nitrogen has the composition of nitrogen in this compound is 41.1100 and on and on and on. Okay, so if you look here, there's 5 significant figures. There's 5 significant figures. This is assumed to be an exact 100, so we didn't write out all the decimal places. But the nitrogen is 41.110. I don't know if I can reach over here. I think I'm going to put it right here, 41.110% nitrogen. Okay, let's look at hydrogen. Now hydrogen's a little trickier. There's 8 of those. So you're actually going to do 8 of 1.008 over 68.144, and there's grams and grams, times 100. Let's see what we get. So 8 times 1.008 divided by 68.144 times 100. So I get 11.8337. So that means hydrogen, again you have 4 sig figs, 5 sig figs, so you can only have 4. 11.83% hydrogen. And then sulfur, 32.066 grams over 68.144. Now I only need one of these because there's only one sulfur in the compound, so I just need to use this in the top, times 100. Okay, so let's look at sulfur. 32.066 divided by 68.144 times 100, and you get 47.0562 blah 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 blah. But we need to go back and look at our sig figs. There's 5 here, there's 5 here, so our answer can have 5 sig figs. 47056% of sulfur. And that's how you do it. Good luck.